Hello, my name's Alan Foom, and today I'm going to talk about risking oil and gas prospects. So it's a discussion. This is a follow-up video to two of my previous videos, one on risking, which gives you a basic primer on how it's done, and another one on why geologists drill so many dry holes, which talks a little bit about the psychology. So exploration is a risky business. About 40% of exploration wells find hydrocarbons, so 60% of them fail overall. And those are the ones we believe are going to work. Only about 30% of exploration wells find commercial hydrocarbons. So when you move into frontier areas where no one's really drilled before, it gets more to be like 10%. So 90% of wells in frontier areas fail. But getting the risking right improves your exploration performance. So we want to try to do better. We're never going to get to zero dry holes because you are taking a risk in a risky business, but you want to get fewer of them. So just a quick recap on how risking is done. More details in my video on how on risking, which I'll link at the end of this video. So you've got elements, reservoir, seal, trap, charge, and source, and all of them have to work. So the chance of success is the probability of each one of these elements working multiplied together, product of probabilities. As you can understand, once you get into the numbers, you start getting relatively low numbers in terms of things that are working. So how's risking done? It's dependent very much on company procedures. Some people subdivide the elements even further. So they look at reservoir effectiveness and reservoir presence, for example. And a lot of companies have pretty comprehensive manuals to try to ensure consistency. It's generally done by the geology team. They estimate the probabilities of each individual element based on their own technical work. And the aim of the technical work is to polarize risk. And I'll talk a little bit about that later, basically kill or cure. And in larger companies anyway, you tend to get effective review by internal auditors. So you have an internal audit team that reviews to benchmark things, make sure that things aren't being massaged, things are done in a fair and a consistent way. You also have review from joint venture partners. Very few companies drill wells 100% equity by themselves. You have a joint venture partner, they have their own opinions. So you want to try to overcome cognitive biases and groupthink, and I have a video on that as well. So subjective probability, this is number of it, because different people have different views of what these things are. So at the top end, you have 100% certain, and at the bottom end, you have 0% impossible. But then, what does highly likely mean to you? I put here 0.8, but other people make that something quite different. Equivocal is 50-50. What does highly unlikely mean to you? And you've got quite a bit of subjectiveness across cultures as well and across companies, so you have a clear scheme which enables consistency. This is a study by Sherman Kent, probability perceptions, that was done by the CIA, I think it was the 1950s. And this is where they had a questionnaire where they asked people what all of these things would mean. So, for example, about even. To me that says 50%, but obviously some people thought it was a bit less than that or a little more than that. Chances are slight. To me that's 10-15%. Other people thought so differently, and then you have some people clearly misunderstood the question, which give you these outliers. But it gives you an idea how different people think. So it's very important when you're risking prospects within an overall company portfolio, which is done by a whole bunch of different people with their own different cognitive biases. So just a little bit on what risk and uncertainty are. So risk is binary. It either happens or it doesn't. Whereas uncertainty is how much does it happen when it happens. What's the magnitude of the event? What's the range of outcomes, assuming the event actually happens? We both need to understand them, we need to quantify them, and we need to be aware of the cognitive biases when we're estimating them. So what are you actually risking? So when you say the prospect has a 30% chance of success, are you risking a drop of oil? Are you risking a volume? Now, the company I worked for, we would have basically getting within the P10 to P90 volumetric range. So volumes would have a range, and I have a video on volumes on my channel. Please check that one out. And you will generally tend to be within that volumetric range. So if it's below, your low case, it's going to be effectively a dry hole anyway. So you would tend to risk it that way. But other companies feel differently, and this is something that Professor Alexei Milkov of Colorado School of Mines posted on his social media page. I really would recommend you check out his material. And he publishes quite a lot of papers for the APG in the APG Bulletin. So if you're an APG member, please have a look at that. So different companies will do that. Now, Exxon are obviously very disciplined, define minimum volume, which is how I feel it should be done. Shell have some movable hydrocarbon. So you'll produce hydrocarbon to surface, whether that'll be enough to do it or not, that's another question. Total have something similar. BP, a wide range. So obviously somebody is not being very disciplined here. Within Petronas, an even wider range. You know, petroleum shows as you got a little bit of hydrocarbon somewhere. That's no good to anybody. Volume that will be produced is a commercial chance of success. So if you put it on here, you would be, let's say the commercial cutoff would be at this range. You would then have a commercial chance of success on top of that, where you take your volume and distribution into account. So the key of geologists' work is getting to a reducible risk. So an irreducible risk is the final chance of success, which represents a residual risk once you've done all the technical studies. Now you do all of these technical studies, seismic interpretation, rock physics, basin modeling, radial sedimentology, pore pressure, fault seals, structural studies, etc. You do all of this lot to try and understand what's going on. By the end of the day, you will always still have some irreducible risk. And the key thing here is to understand when you've got to that stage so you don't waste any more time or money when you have made a decision. And one of the tools we have here is a confidence smile. Now this is developed by Shell. It's been used throughout the industry. So what we have here at the bottom is probability. So 0 means not ever going to happen. 1 means virtually certain, certain. And 0.5 is, even money, 50-50. So you have your greater knowledge level, and you want to be either here or here. Because if you're here, you're not going to drill a dumb dry well. You know it's not going to work, or you're virtually certain it's not going to work, so you're going to go away. You're going to do something else. Whereas here, you're almost certain it is going to work. Obviously, you could have some surprises, but you feel pretty confident it's going to happen. Whereas when you start off, before anything, you're in here. So you have your probability, you have your knowledge, and you really want to get to these two corners, because then that's when you make the right decision, hopefully. Okay, so what happens when you have multiple models? Now, let's say you have a situation where you have some prospects depend on either fault seal or the attic volume above the fault seal. So you have introduce an extra element. So each model has a different cause. So you have also the probability of a model being there. So you have probability of model A, probability of model B. Each model will have a chance of success, and you have a composite chance of success. So probability of model A occurring times the cause of A, plus the probability of model B occurring times the cause of B. So that's how you can have multiple models. But people tend to overestimate risks. So again, this is some more work from Alexei Milkov. Please check this out. He posted this on social media from one of his papers. And what tends to happen is the pre-drill chance of success. So these are pre-drill chance of success estimates from the data that he's looked at. They tend to be much lower than what the actual chance of success of the wells is. Now, these are the prospects that actually got drilled. So obviously there would be some prospects that people just thought it's never going to make it, so we won't do it. But again, significant underestimate of the chance of success, overestimate of the risks. And the reason to some extent is because if there's a dry hole, you don't want to end up looking too stupid. So if you have an 80% chance of success and it comes in dry, you look a bit silly. Whereas if you have a 30% chance of success and it works, you look really great. So again, that might have something to do with it. Again, biases that geologists have. But also, according to Alexei Milkov, people tend to overestimate the pre-drill volumes. And this is actually a fairly serious problem that doesn't tend to get that much attention that it needs to. What tends to happen is that when wells are drilled, they tend to come in less than what people think they would have done. Now, on a very large field, that doesn't matter too much, but on a more small field or a marginal field, it most certainly does, because it'll move from being something that could work to something that's subcommercial. Now, again, all sorts of bias reasons why that might happen. There might be a desire to get something drilled, whereas the causes very strongly policed, the volumes are less so. It could be that people just feel over optimistic about their prospects. But again, it's something that needs to be looked at, something that needs to be worked on. So just to sum up, risking is subjective. Of course it is. We have some information, but we don't have all the facts, we don't have all the knowledge. But trying to do it in a systematic way allows management to compare prospects fairly, looking at apples with apples and trying to see where they are. Then knowing what you're risking. That really needs to be something within an organization where somebody is told, you are risking the recoverable volume within this range. So if you get a bit of shows, you get a little bit of movable hydrocarbon, doesn't matter. It's got to be a volume within this range. Confidence smile, looking at the irreducible risk. That's where we want to get to. We want to have a kill or cure. And also benchmark against previous results. Now, I've got a video on my channel on Bayesian statistics. So if you got, for example, a prospect which has a 40% chance of success and in a play which normally has a 25% chance of success, you need to ask yourself some questions. Now, it could be that this is a particularly good prospect. Fine, you answer the questions, but the questions need to be asked. And the pre-drill volume tends to be too high. And that's something that we really need to work on to get better results, better performance with an exploration. So thank you very much. Please like, please subscribe, and I'll see you on the next one.